Hello learners, and welcome to today's lesson of exponents. Now let's start off our lesson on a did you know. So, did you know that exponents and bases do not play the same role? Yes, the result of 2 multiplied by 3, where 3 is a base, and the result of 2 exponent 3, where 3 is an exponent, are different. This lesson will help you find out more. So let's see what our lesson is going to be about. So by the end of the lesson, you should be able to compare numbers in exponential form, establish general laws of exponents limited to multiplication of powers of the same base and division of powers of the same base. So looking at our concept map for this lesson, so we are looking at exponents, and then the first concept that we are going to look at is comparing and representing integers in exponential form. Then we are going to look at the first law of exponents, and that is multiplication of powers of the same base. Then lastly, we are going to look at the second law of exponents, and that is division of powers of the same base. Let's see what pre-knowledge we must have for this lesson. So you must be able to identify the base and the exponent in a power, expand a power, write numbers in their exponential form, and square numbers and cube numbers. So these are the things that we are supposed to know. And lastly, you must also know how to perform calculations involving all 4 operations using numbers in exponential form. Let's get into that pre-knowledge. So we have been given here numbers, which is a 2 and a 5, and we are supposed to label these numbers or this expression. So firstly, we are going to look at the whole expression, and that is a power. So let's look at the numbers individually. Look at the 2. Do we know what role that 2 plays? If you are thinking of the base, then you are absolutely correct. That is the base within our power. What about that 5 over there? Do you know what role that 5 plays? Yes, this is our exponent. You are absolutely correct. So this is us labeling our power, where we know that a power is made up of a base and an exponent. Let's go on to expanding our powers. Now, just to remind you, remember that when we are expanding our powers, so now we have that example that we just looked at of a 2 exponent 5. So what does this mean? This means that our base 2 will be expanded 5 times. So we have 2 multiplied by 2 multiplied by 2 multiplied by 2, and that is multiplied by 2. Now, if we are going to take this step by step, we know that 2 multiplied by 2 will give us there a 4. And we know that when we take that 4 and we multiply it by 2, that is going to give us there an 8. And when we take that 2 and we the 8 and we multiply it by 2, that is going to give us a 16. And eventually, when we take that 16 and we multiply it by 2, that will give us that 32. So this now shows us that when we say 2 exponent 5, our answer is going to be that 32 there. And we were able to achieve this by doing it step by step. Let's look at others. So we have here a power that is 2 and an exponent 1. So what does that mean? That just means that our 2 is written only once. What about our 2 exponent 3? What does that mean? So this would mean that our 2 is multiplied by itself 2 more times, so that in total we can see that our 2 will appear there 3 times. So that is 2 multiplied by 2, and that is multiplied by 2. Now what would that answer be if we are expanding this? Well, we have expanded it, and if we are going to calculate that, that is going to be 2 multiplied by 2. We know that is going to be a 4, and if we additionally now multiply that by 2, that is going to give us an 8. So we know that our 2 exponent 3 is equals to 8. What about this next one? Let's just expand it. So we are going to expand it. We have an exponent 4. So we have a base 2 and an exponent 4. What does this mean? Yes, it means that our base 2 is multiplied by itself 3 times. So that is 2 multiplied by 2, multiplied by 2, and multiplied by 2. So that 2 is multiplied by itself 3 times. In total, we have 4 of those 2's appearing there. And that is how we would expand a power. And of course, you can go ahead and calculate that. And let's not forget that this also applies to our negative numbers as well. Remember, we are working with integers. So when we are looking at our negative numbers as well, if we have a negative 2 raised to an exponent of 3, what do you think that is going to look like? Yes, that means we are going to take negative 2 and multiply it by itself 2 times. So that is negative 2 multiplied by negative 2 multiplied again by a negative 2. And that is how we would expand that power there. Let's go on to more pre-knowledge practice. Let's write the following numbers in their exponential form. So firstly, we have an 8. Now, we know that 8 comes from 4 multiplied by 2. And of course, if we go ahead and break that 4 up, that is going to be 2 multiplied by 2, which gives us that 4. And again, we are going to multiply by that 2 there. And we can see here that 2 appears 3 times. That means our base 2 has been multiplied by itself 2 times, which means it is 2 to the exponent of 3. Let's go over to the next one. Now, our next one here is a negative 64. Now, a negative 64 would come from a negative 8 multiplied by 8. So negative 8 multiplied by 8 will give us that 64. Now, from the previous one, we've already seen that 8 is equals to 2 exponent 3. So you can go ahead and break up those 8s, or we can just say here that we know that the first 8 there was going to give us a 2 multiplied by 2 multiplied by 2. And then we know that the second 8 there is also going to give us a 2 multiplied by 2 multiplied by 2. Now, what is that going to give us? Let's not forget that negative there. So that is going to be a negative. And we can see that how many times does the 2 appear there? 1, 2, 3, 4, 5, and 6. So that is going to be 2. And that is going to give us an exponent of 6. So now we know that a negative 2 exponent 6 will give us a negative 64. Let's look at that 27 there. So now 27 we know is 9 multiplied by 3. So we know that the 27 is equals to 9 multiplied by 3. Now how can we expand that further so that we can write our 27 in exponential form? So we know that 9 is equals to our 3 multiplied by 3. And of course, we have that other 3 there, so we are going to go and multiply that by 3 as well. So how many 3's do we have here? We can see that 3 has been multiplied by itself 2 times, so that means we have a base 3, and that 3 is appearing there 3 times. So 27 written in exponential form will be 3 exponent 3. Let's move on to our last one there. We have a negative 81. So how are we going to solve for that? Now 81 comes from, so we are going to say there, firstly we have our negative, and 81 is made up of 9 multiplied by our 9. So how can we write that in our exponential form? Of course, we know that we can either say there, from there we can say that it is a negative 9 exponent 2, because that 9 there appears there twice. But another option that we can use is to go on and break down those 9s because we want to write our exponential form in the simplest way. So we have that negative there, and we know that from 9, we have 3 multiplied by 3. Then, of course, we have another 9 there. So that is going to be multiplied by, so that 9 is now represented by 3 multiplied by a 3. And what does this give us there? We can see that 3 is appearing there 4 times, which means 3 has been multiplied by itself 3 times. So that is going to be a negative base 3, and the exponent there is going to be a 4. And that is our negative 81 written in exponential form. Let's quickly go to an ad break and then we'll see you just now.